All right, so we're still working in section 1.1. We're on day 3 of that section. We're going to talk exclusively about domain today. Remember, domain is a set of all real numbers for which a function is defined. We have to exclude values for which a domain is undefined. If you remember back when we were doing some of these problems here, we saw examples like this where the domain, there was nothing there, right? So 2 was not part of the domain. So we're going to look at some situations where a function is undefined, and there's two main ones that we need to focus on. The first one is when the denominator equals 0, and the second one is when the radicand, you probably heard that word before but don't remember what it means, is less than 0. Okay, so real simple. When the denominator is equal to 0, so we cannot have something over 0. That's no good. And radicand is when we have a negative underneath our radical. No good. So those are situations that we're looking out for, and that's how we're going to find these points where our functions are undefined. So we're going to start right into working some examples. It says find the domain of each equation algebraically and write it in interval notation. So when we look at this function, f of x equals 2x plus 4, this is the graph of a line. It has a slope of 2, a y-intercept of 4. So to find the domain algebraically, any value that you plug in for x is going to give you a value for y. So there's not a lot of work to do here. We know that this is going to make a line that goes up 2 over 1, right? Y-intercept of 4. So even though it says to solve algebraically, this is a pretty much, you just look at it and answer it. The domain of any line is negative infinity to positive infinity. So that one's kind of a freebie. Let's take a look at this one. F of x equals the square root of x minus 3. If you were wondering about that word from a minute ago, radicand, this is a radicand. So the radicand is whatever is underneath the radical. And for our purposes, we look back up at our where functions are undefined, it's when the radicand is less than 0. So we want to make sure that x minus 3 is greater than or equal to 0, because that's the only case where this function would be undefined, is when the radicand is less than 0. So we're going to go straight to finding out where the radicand is greater than 0, and that's going to tell us our domain. So we add 3 to both sides. X is greater than or equal to 3. And if you're not sure why we're doing this yet for a second, that's okay. We're going to take a look at it. So I'm going to draw a quick little number line here. So just like the ones we did before, we're going to put 0 and 3. And what I did here tells us that our domain is everything greater than or equal to 3. But you may not really be sure why we did that. You may just be writing down what I do and not really sure why we're doing any of this. So I'm going to draw a quick graph. Go ahead and draw this. And again, this is really quick. When we graph this function right here, what we're going to see, and we'll learn all about this later, is that this 3 causes our function to move to the right 3 units. So it's going to start here, and hopefully you remember that square root functions look like that. And so without maybe understanding exactly why we did what we did, hopefully you can see that the domain of this function graphically goes from 3 on to infinity. So that's why we need to make sure that whatever's under the radical is not less than 0, because if it's less than 0, that would make us over here, and you can see that that function doesn't exist there. so it's undefined. All right, so here's a little example. F of x equals 3 over x plus 1. Remember, this is what we talked about. This is the denominator. And we cannot let that equal 0. So what we're going to do is make it equal 0. And we're going to find out what does x equal when the denominator is 0. So if we looked at a number line for this function, so we can pick any values we want to plug in for x, but we cannot pick -1 because that'll put a 0 in the denominator. So -1 is out. But we can put every other value that we want. We can put all kinds of stuff less than -1. We just can't put -1. So the domain here is -infinity to -1, not included, union, -1 again, also not included, positive infinity. And so that's what this is what we're trying to get today. This is the goal. And back up here, I didn't write the domain on this one, but the domain would have been from 3 included to positive infinity. Sorry about that. All right, so moving on. We got a couple more examples, and I'm just going to do one more and let you finish the rest. So I think you can do number 4, probably make it through number 5. I'm going to go ahead and look at number 6 for you. So on number 6, we have two situations. We have a denominator that can't equal 0, and we also have a radicand that has to be greater than or equal to 0. So we're going to work on both of those. So the denominator, we add 2 to both sides, and we get that x equals 2. So that makes this undefined at x equals 2. Then we do -1, -1, and we get x has to be greater than or equal to -1. Well, so you got these two values, and we need to figure out what to do with them. We'll go ahead and do another number line, because I like them. And I'm going to put these values on here. So got 0, 2, -1. So first let's figure out what is going on at these places. So when x equals 2, the denominator equals 0, which I don't want. So on 2, I'm definitely going to cut that bad boy out. He's not going to get to be a part of the domain because he'll make my function undefined. But I'm also got a situation where x needs to be greater than -1. So it can be equal to -1. That's okay. It's got to be greater. So it's going to go along like this. And then what happens when it runs into this spot? Let's just skip right over it, right? And go that way. And what we have, if we graph these things, if we graph this, we would have a graph that started at -1, and it would go and do whatever it does. Maybe it does this, maybe it does this, but it would start at -1. And when it got to 2, it would have a hole in the graph. So there would be a hole, and then it would continue on. So you guys go ahead and work the rest of them, and come in tomorrow with any questions you have. Have a good evening.